you're watching this. This is the second part of section 2.2 in Algebra 2. It's a lot of twos. If you remember on Monday in class, we were talking a lot about slope. We spent a lot of time talking about what the slope of a line is, what that means, and we didn't quite get through the rest of the questions. So I wanted to go over those with you so you could go ahead and complete your homework. So if you remember, we talked about what the slope of a line is, and we described that as the rise over the run, or the change in y over the change in x, or there's even an equation that we wrote for that. So let's go ahead and write that up there. So just to remind ourselves. So the slope, if you remember, pen out here. The slope is written as m, and we were going to look into why it's called m, right? The slope m is the change in your y coordinates. Let me scoot back a little here. There we go. Change in your y coordinates divided by the change in the x coordinates. Okay, so we didn't get to do, I think, problems 2, 3, and 4. So let's go ahead and dive in and take a look at those. So question 2 says, tell if the lines are parallel, perpendicular, or neither. And what we're given is 2 lines, and we're given 2 coordinates on each line. So line 1 is at 3, -1, and 6, -4. And line 2 is at -4, 5, and 2, -7. So there's a few ways that we can do this, but what we want to do is we want to do this mathematically, and then we can always check this on our graphing tool. Okay, so one of the things that we talked about on Monday was that we can tell if lines are parallel or perpendicular based off of just the measurement of their slope. So if you'll recall, lines are parallel if they have the same slope. So the slope of the first line equals the slope of the second line. Lines are perpendicular if the slope of the first line is the negative reciprocal of the second line. So we're going to look and see, is the slope of line 1, we'll call that m sub 1, and the slope of the line 2, m sub 2, are they the same? Are they reciprocals, negative reciprocals of each other, or are they just totally unrelated? So the tool that we needed to do to figure this out with is just to use our slope equation. Okay, so what we're going to do is we're going to say, okay, well, the slope of line 1 is going to be my change in y's divided by my change in x's. And just a reminder, make sure that your points are lining up with each other. So I don't want to make too many marks. I have -4 and 6. Those are lining up with each other, right? And I have -1 and 3, and those are lining up with each other. Okay, so I have -4 minus a -1. That's just like adding 1. So that's -3. And I have 6 minus 3, which is 3. So it looks like my slope for line 1 is -1. Okay, so then I need to switch it up and find my slope for my second line, which is m sub 2. Okay, so again, if this confuses you, you can always label. So I could say this is x1, y1, x2, y2. Or if you can just do it based off of looking at the points, you can do that as well. So y2 is 7 minus 5 over -2 minus a -4. 7 minus 2 is 2. -2 minus a -4 is going to give me +2, right? Because this negative minus basically means add 4, and I get 1. Okay, so I have the slope of the two lines. Now I have to figure out what that means. So first off, I have the slope of line 1 is -1 and the slope of line 2 is 1. So that rules out that they're parallel. They would have to have the same slope. One is positive and one is negative. So one's rising and one's falling. They're definitely not going in the same direction. All right, so my second choice is, are they perpendicular? Well, they're perpendicular if they're the negative reciprocal of each other. This one's a little bit interesting of an example because we have the number 1, so it's a little bit harder to see. But the definition of a negative reciprocal is, does M1 equal negative reciprocal of M2? Well, M1 is -1, and then we want the negative of 1 over 1, which is -1. So it appears that these two lines are perpendicular to each other. That's the sign for perpendicular. Okay. If we really want to double check, what we can do is we can switch over to Desmos, or we can just do a quick plot. Since I don't have Desmos up, I'm not going to do that. You can always make, oops, computer thought I was doing something else. You can always make a quick plot, right? Excuse me while I draw my hash marks here. Okay, so we have a point at, and I should have color coded these. We'll make M1 red. How about that? So we have a point at 3, -1, right there. We have a point at 6, -4, down here. So this is our line M1, and look at that. It's got a, what's it doing? It's falling, right? It's got a negative slope. So M1 has a slope of -1, so it's falling. So that makes sense, right? Okay, M2 has a point at -4, +5. Oops, kind of running into each other here. And it also has a point at -2, 7. I ran out of room up here and do my graph right. Let's see. I think I can scroll up. Oh yeah, there we go. -2, 7 should be somewhere up here. Well, I kind of failed on my quick graph here, but this is my second line. And if I would have graphed them out the right way, I think we're going to end up with a nice perpendicular line there. So, okay, so that is how we do number 2. Number 3 and number 4 aren't quite as complex. They're just a little bit of taking slope and applying it to the real world. So number 3 says, state the rate of change. And then I wrote, which is likes the slope. Okay, so this is when you have some coordinates, and we're going to talk about those coordinates as real world measures. So in this, we have two sets of coordinates here, 2, 12, and 5, 30. And we're saying that X is the measure in hours and Y is the measure of dollars. So a lot of times a standard unit of measurement, a rate of change, is we measure dollars per hour. You heard that before? Or we do miles per hour. Well, it just so works out that Y is measured in dollars and X is measured in hours. The change in the dollars over the change in the hours, right? And this is slope. So we can use our slope equation also when our rates match up to the rate of change. So looks complex, but it's actually easy because we're going to find out the change in dollars over the change in hours. And to do that, we're just going to use the slope equation. Okay, so the rate of change, so we'll call this the slope of the rate of change, just so we can keep it clear with all of the other scratch work that's on here, is going to be my change in Y divided by my change in X. Okay, it's nice that these are not negative numbers, right? 30 minus 12 is 18. 5 minus 2 is 3, and we get 6. Now, because we were using a unit of change, or we were using a rate of change which has units, we need to think about what units we have on here. So y is measured in dollars. So here we were talking about dollars, right? And x is measured in hours. So we were talking about hours. So if you look at what the rate is, we were talking about $6 per hour. So it's just an application of using the slope. You just want to match up what your unit is that you're using for y and the unit that you're using for x. And then you're able to use the slope equation to find out the rate of change. Okay. And then the last one, there's nothing extra special about that except number 5, except that we have some fractions in there. And sometimes when people see fractions, they're not so crazy about it, but I'm going to show you it's going to work out all right. And we'll use purple in homage to the purple marker. Okay, so find the slope of the line passing through the given points. -3/4, and then -2, and then 5/4 and -3. So when you see fractions, that doesn't mean that you cannot use the slope equation. You can still use it. We're going to use it the same exact way that we did before. So we'll call this the slope of the fraction points. Okay, so it's going to be my change in y over my change in x. Fractions in the denominator, right? It'll work out all right. So the change in y is easy, right? 3 minus a -2 is just going to give me -1. 5/4 minus a -3/4 is just like adding 3/4, right? And thankfully, they've given me fractions with the same denominator, so I can deal with that because that means I just add the numerator. So 5/4 plus 3/4 is 8/4. And we don't really like fractions in the denominator like that, but thankfully 8/4 is just 2. So my slope of these lines is, -1/2. So just because you see fractions doesn't mean that you have to do anything fancy with that. So that is the end of 2-2. We will talk about 2-3 on Friday, and I hope you have a good rest of the week. Thanks. Bye.